All right, good morning, folks. Hello. What have we here? Una mariposa. There you go. It's a good omen. That means that he's lost. Butterfly's lost. Not sure where he was going. Solar eclipse. One thing. It's all about the speed of light. Now, so we have finite light, don't we? The solar eclipse that we see, oh well, what you see anyway, that is, it's finite light. So you guys, you have photons leaving the sun. They take 8 minutes and 20 seconds to, when it's not solar eclipse time, we call it 8:20. But because it's solar eclipse time, we call it 8:20 plus 1.3. Just that last extra mile. So 8:20 photons. But the problem we're having is it's not adding up, is it? Because there doesn't seem to be any light delay. I say this because the moon seems to be blocking the light source itself, doesn't it? Not photons. So we cannot see any invisible massless packets of invisible massless photons anywhere. They are not present during the solar eclipse. Now, a while back I said, so how would a solar eclipse with absolute light play out? And I never followed it up. So I'm thinking this morning it'll be a good time to just follow up on that. So what we'll do, we're going to run through our heads, just a quick diagram, and we're going to, let's just see if we can work out how a solar eclipse would play out with absolute light. Because we have one with finite light, but we want to know how it would play out with absolute light. Can you see where I'm going with this? Okay. Now remember, I don't have any qualifications, no PhD, so forgive me if I'm a bit clunky around the three things, the sun, the moon, and planet Earth. So what we have, we'll do it properly, but we'll do it fast. We're not going to mess about, are we? I'm sure that we'll come to some kind of a standstill. We'll get caught up on something anyway, because there must be, or I'm obviously missing something. Right, so we have a sun. Let's go this way for a change, shall we? So we have a sun. Right. This is, now we're doing, this is how I think it would play out. Absolute light, okay? We'll put the moon here. We don't need to go massive. Right. I'll give Daisy the cow a little mention. There you go, Daisy. And then Earth, not to scale, remember. That here. Right. So, absolute light. How do we think things would play out? So it's the moon that's moving. So I'm pretty sure that the sun would be shining with absolute light. It would be boom, like all the grass would be green. There would be no waiting around for photons to come and tell us green grass and blue books, that kind of a thing. Everything would just be as it is. Everything would just, what you see is what you get. Really good, I think, right? Just no waiting about for the photons and the retinas and the rods and cones. It's a drag, isn't it? But anyway, we're talking about the solar eclipse. We've got sun, poof, absolute light. And then the moon comes along, and as soon as the moon blocks the sun's light, right, what we'd expect to see is what happens, isn't it? Or is it not? So the moon blocks the sun's light. This, if it was absolute light, hang on. The moon, and people see the corona probably, wouldn't they? That's a coincidence, isn't it? That's a big coincidence. That with absolute light, the sun's corona, it would be visible around the moon because it's absolute light. It's instant. There's no delay. It's a bit like the other one, but I don't know. Anyway, so the people on planet Earth are looking that way, and they're in the sweet spot shadow. We know all about that, don't we? But remember, it's absolute light we're doing here. And then we've got this down like that, and then we've got that like that. I tell you what, this is remarkable, because if I didn't know any better, right? No, can't be. It is, Look, we need to get some qualified personnel onto this, because I could be missing something big. Good night. But I've got to say, now that I've got it on the board and I'm explaining it as absolute light, if the sun radiated absolute light, it's ever so close to the one that we have already. But the one with finite light still plays out like the one with absolute light. Isn't that bizarre? Oh. How come there's two Daisy the cows? Why is there a Daisy the cow over there? It's a stupid question, isn't it? It's like, how does light get from there to there? Same kind of question, really, pointless. But no, it's all the speed of light, and you age slower and everything slows down if you reach, the faster you go, and then the wormholes and the black holes and the poof, and just everything, the relativity, all of it. I mean, but wouldn't it be weird, wouldn't it, if it turned out to be just one like big old whopper, not with cheese either, I mean a lie. Wakey, wakey. It's not often somebody come along like this and give you all a nudge. Hey, show you how the game is being played. Seriously, wakey, wakey. This is like your every Netflix adventure, thriller, horror, psychological thriller series you've ever seen, all in one, isn't it? And a little bit of comedy thrown in, don't you think? So we have a solar eclipse with finite light, just in case you just joined us, right? Solar eclipse with finite light over here, right? But it's really very, 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 it's so close. It's closer to absolute light, the way it plays out, than it is finite light. I say this because there is nothing that would suggest finite light. Nothing at all. And absolute light, if it was points, like if there were 100 categories where we would say, right, that has to be absolute light, all of them would go to absolute light. Nothing would go to finite light. Yet here we still are, right, arguing that when the moon is directly in front of the sun, right, that it's 8 minutes and 20 seconds old, even though it's not. It's clearly not. It's clearly absolute light, okay? But it's not. It's finite light, isn't it? But then, when we go over to this other board, and we say, right, let's tie the loose ends up, right, and go over a solar eclipse with absolute light. And what do we find? Oh, things. It's a mirror image, isn't it? It is. Because this planet Earth, in 8 minutes and 20 seconds, this planet Earth will spin on its axis by 2.08 degrees, the same as that one. This is uncanny. It's almost like, that's got to be. What am I missing? Not common sense. Definitely not common sense. If I were missing common sense, that light, it could be travelling at any, you could pick a speed. If I had no common sense whatsoever, I could say 8 k's an hour. It's going to take 3 years to get, so it's going to be a really slow process, a solar eclipse. Just joking. Look, I can see what's going on. I'm trying to nudge people. Give you a little bit of a look behind the curtain, right? But everybody's digging their heels in. We've got the qualified personnel with all the badges and the bells and the whistles, but they're nowhere to be seen, right? Such a big issue. Age of the universe, stars in the night sky. They're not there, you know. That one could have been snuffed out already. It took 20 years for that light to get here, huh? That kind of thing. Age of the universe, the Big Bang Theory, gravitational waves, LIGO, the Laser Interferometer Gravitational Wave Observatory, all of it, relativity, magic, communications, because if Mars, voyages, can you imagine? Can you imagine that all those things, I mean, we've been over the eclipse and it, hang on, it is, isn't it though, isn't it? Look, I'll leave you with that one, and if any of the qualified personnel feels up to it, just an explanation. They've got explanations for everything. But when it comes to the biggest, the most magnificent of all celestial happenings that we can see, our moon blocking my sun, right? And there's no logical explanation. How is it even possible? Well, I know how it's possible. I'm just playing along for you guys. So hopefully you're all at home like suspense. Absolute light. Absolute light. Alright. I don't want to be this sarcastic ever again. This smarmy and horrible. So I hope it's a wrap. It was fun though. I did enjoy that. La luz es absoluta, que no hay ningún retraso, que es instantánea, joder. ¿No? Venga. Cuidado. ¿Quién es yo tan raro? Later, peeps.